Hello, today we are going to be taking a look at this absolutely beautiful 12-volt car electric kettle that is being designed to be operated from 12-volt cigarette lighter output, but of course my plan is to use it with solar installation and portable power bank so I can make something hot in field. When you take a look at 12-volt car appliance, there is absolutely a lot of different models to choose from. I decided to go with that one from two reasons. The first reason is, if you take a look, the power draw on that unit is only 80 watt. So this should work absolutely very well with portable power banks. That looks, for example, like this with portable power station that's got a cigarette lighter output. You really don't want to pull like a crazy amount of amp from it. Second reason, you will see after opening this top part, and if you see, the internal heating chamber is being shielded around with that plastic insulation, and most likely there will be some sort of foam. So to some extent it's acting as a vacuum flask and it's insulating the content from the environment. So it should be really good. Let's take a look at the first impression. If we take a look at the power cable, the impression is extremely good. We've got a really thick cable, but that is going to be extremely quickly turning into disappointment as soon as we read the wire specification. And if you take a look here, if you can see that, this is 2 times 0.75 millimeter square. So this is really thin wire, and they decide to put it into that really thick insulation. And I've got most likely reason why it's being done that way. I'm not sure if you can recognize that style of plug, but this is something that you can find on most laptop power supplies. And yes, you bet you can plug this cable into laptop power supply, and vice versa, you can plug this AC plug into our kettle. So this is extremely dangerous if someone is not going to be paying attention to the information, because you can plug it into your mains AC and blow it up. So this is not a good design choice, and most likely that's why this cable is thick, because it is just a regular cable designed for AC. So yeah, this is a bummer. But let's make a visual inspection. So here is your label. It should hold 350 milliliters, and this power connector is being hidden away by that rubber silicone flap. Absolutely beautiful. We've got some sort of carrying handle. It is made out of plastic. We've got our power switch with the LED indicator. On bottom, I do not see anything interesting. Inside looks like steel. We've got that insulation. Here is our top cap. We've got a silicone on the outside. Plus we've got like an emergency vent. This of course is not being created for drinking, but to make sure the internal pressure is not going to be ripping it apart just when you start to boiling it. So when you are going to be operating it as a heater, then you should make it open, and here the vapor can escape. And here is our beautiful cable. We are going to be plugging it in. Of course, absolutely do not get negative impression that the wire is too thin, because this is a 80 watt model, so it should be fine. The intended use case is going to be, of course, powering it from my Goal Zero or different power station, and that's why I was making sure it is a low power device, so that 80 watt is going to be capable of being delivered from devices like this. And when we switch it on, yes, of course, it's working and it's not blowing any protective fuses. But because I would like to check how long we need to wait for boiling our water, we are going to be using power supply to make sure that we've got constant voltage and constant power. For our test, I prepared 200 milliliters of water that is going to be used for brewing our test tea. It's got a room temp, as you can see, of around 20 Celsius degree. And we are going to give it a spin. So let's put our water in. So we nicely pour it just like that. And as you can see here, we've got like a max fill line. We are going to protect it and make sure that we've got that element open so it can vent. Then we are going to be applying 13.8 volt from my power supply, the positive on the tip and the negative on the side, just like that. And now we are going to be trying turning it on, and of course we need a stopwatch. So power on, and the time is started. If you take a look at the power supply, we are pulling 6.6 amp at 13.8 volt, and that translates to 91 watt, which is absolutely beautiful. And around our 12 volt, when the battery voltage is going to be a little bit lower, we are hitting the 80 watt that was promised. So yeah, that part is 100% fine. And let's give it a try. Let's see if we can see any bubbling. And on bottom, I can see that something is forming. Let me stick my finger, and it's getting warmer. It is not hot at all. Let me stick our probe, and we've got currently 40 Celsius degree. So we already rise our temp by 20 Celsius degree. So the device is operational, and we need to find a better way to put the stopwatch. As you can see, we hit our 10-minute mark. So let's take a look how the boiling process is working. And I can see that we've got some bubbles. And let's see what kind of temp do we've got after 10 minutes. We've got around 83 Celsius degree, which is totally fine. In many cases, that would be more than enough if we've got like a safe water to just bring the temp for brewing. But let's give it additional 5 minutes and let's see where we can get. We just hit our 15-minute mark. And I can clearly hear that we've got a boiling process inside. So let's do a reveal. And as you can see, we've got a steam and we've got bubbles. So let's take a look what kind of temp did we achieve in that 15-minute mark. We put our probe, and as you can see, we've got around 100 Celsius degree. So this is 100% fine, and we can brew our tea. And I'm pretty sure someone of you might get impression that I will put the tea bag here, but of course we are not going to be doing that because this is not a good safety. The good safety is only using for drinking your regular cookware. So here we've got a mug. I turn it off, and we put it here. And let's take a look what kind of color did we get. And as you can see, we've got a good color. So that device clearly managed to make our tea. So as you were able to see, this device worked absolutely beautiful and managed to make our tea. So thank you very much for watching. I hope you find that interesting. See you next time and bye bye.